Okay, the rain has stopped for now and reminds me of the song "The Rain is Gone and I Can See Clearly Now," or "Can See Clearly Now, the rain is gone." But the wind is very strong and rain is really not gone. Monsoon keeps doing this on and off thing. So let's wrap up this particular staff note summary with one podcast here, focused on international aid and cost benefit analysis amid large risks and deep uncertainty. So climate scientists jump up and down a lot saying how important climate action is, and they think their science is really ready to be consumed directly to drive policies and decisions. But unfortunately, it's not so, because there are large risks and deep uncertainties, and politicians have to make decisions and pay a price in terms of elections, whereas scientists can provide they call decision support and this and that, but are they responsible for the decisions? They are not. So we have to keep this in mind, especially for adaptation. International aid. At the global level, there is growing demand to increase international aid toward low-income, vulnerable countries with large climate change adaptation needs based on equity arguments. Right? This is at the global level. While efficient adaptation to the present climate remains an issue in many countries, climate change creates new risks for low-income and vulnerable countries, and the Indian subcontinent, Indian Ocean Rim countries are a good example of that. These risks are expected to increase inequality within countries and relative to higher income countries, even if lower income countries have typically not contributed much to the climate change themselves in terms of emissions and accumulated emissions, and the warming and the impacts. Conditionality of international aid on investments in adaptation is a double-edged sword. Development partners can choose to condition their support on using such support only toward adaptation goals. While such conditionality may facilitate the mobilization of resources towards vulnerable countries, it may also lead to invest in adaptation projects that contribute less to society's goals than other development projects. Adaptation to climate change is only one of the many competing development goals. International donors should thus weigh the costs and benefits of investments in adaptation against those of alternative uses of international aid. If adaptation finance is not additional to existing development assistance or does not have other such strong development benefits. So when international aid is given, if it insists on focusing only on adaptation and not worry about development goals, which would work better to make the country resilient in many ways by increasing education, access to water, energy, health, etc., then remember what we said before. We said the core benefit of development over the century has been to reduce the number of deaths to the least among the list of causes from natural hazards. Whereas cardiovascular diseases are at 31%, natural causes cause 0.2% of the deaths per 100,000. And cardiovascular diseases are not spread equally across the globe. Poor countries have higher burden of cardiovascular diseases. So how do politicians make decisions on development which may improve health versus climate adaptation, which is being put as a condition by the international aid? So these are difficult challenges. Cost benefit analysis itself is a challenge amid large risks and deep uncertainty. CBA can account for risks with known probabilities by weighing the net present value in future scenarios using their respective probabilities to calculate the expected NPV of a project. However, the effect of uncertainty on welfare is lost in the aggregation method. Okay, you do things and then NPV is an aggregated value, and it may miss all these distributional effects. If preferences are risk neutral, the probability weighted NPV provides the correct estimation of society's willingness to participate for the adaptation program. However, the risk-averse preferences However, with risk-averse preferences, risk can matter. So let's make sure what is WTP. I always keep its willingness to do something. We looked at it before. Let me search here. So this is the problem of doing these things and not willingness to pay. Sorry. Okay. Should be obvious, right? Okay, so willingness to pay, where was I here? So CBA, society's willingness to pay for adaptation program has to be estimated in the probability weighted NPV instead of just some aggregate number. Okay, so idiosyncratic risks that can be pooled and covered with actuarially fair insurance, uncertain future outcomes can be reduced to certain outcomes. This is a key assumption, key tool, key approach, key analysis of dealing with future outcomes, which can be reduced, which can be uncertain, but they can be reduced to certain outcomes. When a program value depends on systematic risks, for example, the catastrophic failure of coastal protections in a small island state, or hypothetically a large asteroid collision, pooling risks is difficult or impossible. The benefit of a program that could be measured by estimating the willingness to pay for the program before knowing the actual future outcomes, which is known as the option price, right? This is the benefit of the program. This method accounts for the large welfare cost from rare but potentially catastrophic outcomes. Low probability, high impact events are always difficult to deal with. Could be tsunami in the Indian Ocean, for example, the 2004 tsunami, which killed hundreds of thousands of people in Thailand and across the rim countries. Led to quick action, India's investments in a tsunami warning system, but then another tsunami may not come for a very long time. Unfortunately, the estimation of the option price is not simple, so this is a challenge. As many factors that affect benefits and costs of long-term adaptations are affected by deep uncertainty, which we looked at before, CBA may have to be complemented by alternative decision methods. A measure of social net benefits can be developed under alternative scenarios. With this information, policymakers can make informed decisions that reflect society's attitudes towards risks with known and unknown probabilities. For example, policymakers may select solutions that deliver acceptable outcomes in most scenarios instead of solutions with larger expected benefits with the highest probability of large negative outcomes. So how you make these choices is not trivial. Finally, how should adaptation unfold over time in practice? This is the most critical part, right? Decision making under uncertainty can be very complex, and a complete treatment is out of the scope of this note. It's useful to conclude with some practical suggestions on how to frame the process of adaptation to climate change, which is what we will do, and leave this particular set of podcasts and then move on to other aspects of economics, fiscal policies for integrating adaptation into development agenda, etc. Adaptation should not be considered a one-time adjustment, because climate will continue changing over the entire century and beyond. So it's a dynamic process in that sense. Amid all this uncertainty, when could governments start planning adaptation to climate change? Adaptation as a process should start now, because climate has changed and will continue to change. So India is, for example, most of the global south is facing extremes in terms of heat waves, droughts, floods, cyclones in some cases, and you have the changes in duration, intensity, and frequency of events that are happening. Seasonal heat wave existed, but now duration, intensity, and frequency of heat waves are changing. Monsoon has had active break periods through its evolution, but now the rainfall extremes in the duration, frequency, intensity of active break period distributions are changing. So in some sense it's good that active break period is an intrinsic time scale for monsoon, but then your adaptation has to focus on predicting those better and how they are changing, etc. So they're tricky, you know. It's useful to consider separately adaptation that requires capital that depreciates faster than climate change, and adaptation which requires capital which depreciates more slowly. So this is about the future discounting, which is, is it an analytic question? Not really. In the first case, adaptation will likely occur as a sequence of gradual adjustments over time for which long-term planning is not necessary. So you make steps. Farmers who switch crops as a response to higher temperatures will slowly select the capital needed to grow new crops. Alternatively, there can be large differences between climate at the beginning and at the end of the lifetime of some critical infrastructure, including transportation networks and water and other public utility systems. At any point in time, this kind of long-lasting capital will likely be suboptimal because investment choices are discrete while climate change is continuous. Okay? So therefore, it might be cost effective to adjust project designs to allow for cheaper modifications in the future, namely real options, for example, building larger than needed foundations for seawalls to allow for future increase in their heights. In other cases, advanced planning can help to save costs, for example, using zoning regulation to move urban areas away from exposed coastlines by banning new constructions within a certain distance to the coastline and by gradually increasing this distance over time. This is human behavioral issue, and there are lots and lots of oppositions from developers to this, even in a rich country like the US, or maybe particularly in a rich country like US, because skepticism against or denial of climate change is very high in this country compared to, let's say, Europe or even countries like China and India. Allowing faster depreciation of capital that is not climate resilient could free up resources that can be used for more resilient capital. Various optimizations are needed. A practical way forward may be to start addressing adaptation gaps to the present climate, especially when they are large and involve short-lived capital. So India, for example, is already facing heat waves and extreme events, crop damages, health issues, etc. So should it really worry about 2100, or should it really start addressing adaptation gaps to the present climate itself? I'm a very strong believer to do actions that matter now than to keep doing big mitigation plans for 2100. Okay. For climate change projections at the local level, governments can consult climatologists who can interpret and adapt available knowledge to the local situation, but this is very, very, very tricky. As I mentioned, saying that the Uttar Pradesh heat wave became twice as probable because of climate change is climate knowledge, but it doesn't come with any solid statement on how uncertain this information is and what the consequences are. So how do you actually release this information without worrying about the consequence? Each location has its own challenges and uncertainties. However, it's possible to highlight some recurring features, so you can have these points. When the investment horizon is up to 20 years, the natural variability of climate will likely be much stronger at the local level than most of the underlying climatic trends, with the general exception of temperature and sea level rise trends. Model uncertainty is dominated by natural variability over this time horizon, as we said before, and scenario uncertainty is also limited up until approximately mid-century. These have to be used very effectively and efficiently and robustly to protect everything against present climate that is already here. Future is here. Climate change is not the future. For investment horizons of 20 to 30 years, model uncertainty is the most important source of uncertainty. The full set of scenarios produced by climate models should be used to study the distribution of future temperature and other climate variables, including extreme events. This distribution cannot be interpreted as an objective probability distribution because the exact probabilities of each scenario are unknown, which is the deep uncertainty. The average outcome should be interpreted as the best estimate, not as the expected value. So we're getting into technical jargon of statistics, but still these are very critical. For investment horizons longer than 30 years, scenario uncertainty becomes dominant. Analysis should consider model runs for different scenarios separately and apply robust decision-making methods under uncertainty to consider the possibility of very different climate change projections. Emission scenarios should be matched with appropriate socioeconomic scenarios. I have more than a dozen podcasts on evolution of scenarios, their usefulness, their applications, and the need for evolving them into the future for making better projections of regional impact. So you can look at those, which is very critical for this investment horizons longer than 30 years. Finally, uncertainty declines sharply as we move from local to regional and from regional to global scales. Models are very good at doing global scale changes in temperature, sea level, etc., but nobody lives in global mean temperature or sea level. So how do we use this scale dependence of uncertainty? We do not know exactly yet when, where, and by how much, but we know that temperature will increase, that sea level will rise, that glaciers will melt, and that extreme climate events will become more frequent and more intense in at least some regions. But it's very, very important to know in which region you are. This means that solutions should be developed now, even if we only know later when and where these solutions will be needed. Innovations that make adaptation capital flexible will be particularly valuable. For example, seawalls that can be upgraded if sea level rises faster than previously expected, or offshore wind farms that are floating so that you can move them if winds change direction or strength, etc. Even seawalls potentially may be movable if by design, and so on. So incredibly important investment decisions depend on such deep uncertainties. So cost-benefit analysis has to really include these. So when people jump up and down saying climate action, they don't really have a 360 view of these issues. And I'm always scared, sometimes more scared, of ill-informed climate scientists without a 360 view than climate change itself. Yes, I said it, so harass me if you want. Okay?